we're going to talk about safe systems, right? Because we're both engineers and that's what we do for a living. And isn't it really cool that we all want to be able to build Lego building blocks of medical devices? And we want to be able to put these things together and rapidly deploy them and on reusable infrastructure, right? So that we can create these things in record amounts of times at an order of magnitude less cost, right? That's a grand vision. So who in the audience is a systems engineer? Or a closet systems engineer? So I evolved as not a systems engineer. And after being beaten up enough on system safety, I became a systems engineer because I also drank the Kool-Aid. So we want to be able to implement these systems to address the safety issues and rapidly deploy these things, right? I mean, that's a great and wonderful goal. But we currently have chaos, right? And as Dr. Goldman, if you listen to him enough, he talks about the medical errors and the patient problems that have arisen from them. And you don't see them showing up in any official statistics. And this is Julian's estimate. And you can see the date is from 2017. I'm sure that hasn't gotten any better, but lots of people are, die, injure because of medical errors, preventable medical errors. And we've seen, remember To Err Is Human, right? When was that? 1990 or whenever that came out. And national academies have put that together, all kinds of things. We haven't been actionable yet. Right? What's the problem? Tracy referred to some of the systems, and I remember putting this slide together with Mike Robbian, I think it was close to 20 years ago. We were saying, we need to define what the interfaces are, and we need to define what the boundaries are. And we said, okay, which one, right? Each color here, and it's not important that you can see anything really, it's just each color is a different system, right? So if we don't have a common idea, a common vision for the system that we're working on, we're not going to be safe, right? And so part of the research efforts here are to define what the systems are, define what the boundaries are, so that we can have a conversation about what information is crossing those boundaries. And then we can start talking about the data that we need for safety. There's obvious data that comes out of medical devices, right? The stuff that comes out the back panel, right? Just plug in your cables and you get that information. There's slightly less obvious data that's on the front panel that the clinician is pushing the buttons to make decisions. Then there is even less obvious data about what's going on inside the box. Like all of a sudden I'm going into a calibration loop. And if I don't tell my clinician that I'm in a calibration loop, they see some very strange output waveforms. That's metadata, right? It's very easy to capture from an engineering perspective, but we don't capture it and we don't communicate it. And so if I'm coming along and I want to build an app that does some really cool stuff that connects all these things together, I don't know what's going on. And I enter an unsafe situation. And that's why from a systems engineering perspective, right, we push down from the top. And that's why the job one of MDPNP is to look at clinical scenarios. How do we extract the systems engineering requirements from those clinical scenarios? Right? Which system are we looking at? There's lots of different pieces to this quilt, and part of Julian's leadership has been to bring those different pieces to the table. And we need to all be part of the solution, right? We need to all say, are there any parts of this quilt which we are missing? And unfortunately, due to Microsoft's wonderful things, I could only put 8 things in the quilt. I couldn't find a quilt that had 9, but anyway, and there are regulatory components. I mean, my particular Office of Science and Engineering, we're in the labs, and one of our missions is to build what we call regulatory science tools. We want to know where are the pain points, where are the barriers to innovation and to assessing safety, because we want to be part of the solution. And we have an engineering cadre of people working on different aspects of this. And we want stakeholder input to say, these are the places that we should be going. And I'm going to turn it back over to Anura to complement this area.
Thanks, Sandy. So as Sandy said, I'm Anura Fernando with UL Solutions, which many of you may know as Underwriters Laboratories. And we too are here to help, but you have the choice to say yes or no to us. But before we get into the slide, we have a couple minutes here and just one slide to cover still. I want to tell you a little bit about my first week at UL. So when I started there, they told me that I was going to work on vacuum cleaners. And so they also told me that my first project was going to be in the lab, because we all have to start in the lab. And so when I went into the lab, there was a crusty older lab technician in there, probably about the same age I am now when I was in my 20s starting off there. And he told me, well, he didn't tell me anything. He just kind of looked at me and he pointed to this vacuum cleaner that was sitting there. He's like, okay, start vacuuming. There's a strip of rug here. Just keep on vacuuming. And I said, how do I know when to stop? He's like, well, you're the safety engineer, figure it out. And here's the standard. And he tossed it at me. And so I had to sit there and take a look at what was going on in there and figure out when I could stop pushing the vacuum cleaner back and forth. Well, safety engineering is really, it's a discipline unto itself. And so we've taken a lot of concepts, that this community has learned from a lot of different standards entities and so forth, and kind of pulled them together and tried to bring them into the context of medical device interoperability. And so when we take a look at some of the things that have happened, standards development organizations have started collaborating really well too, more recently. For example, AMI, the Association for Advancement of Medical Instrumentation, and UL got together to put together a standard called the AMI UL 2800, which really pulls together some of the concepts from ICE that you've already seen from originating from the F29 committee. And we tried to embody those in concepts called safety, security, and essential performance objectives, and then got adapted into core safety concepts. So when we look at how you address safety with a product or a system, it starts off with analysis. And that analysis takes us to an understanding of what's going on. If I'm pushing a vacuum cleaner, how do I know when to stop, right? Well, there are different things you have to think about. You have to think about the motor that's inside that vacuum cleaner and how hot it's going to get when it's being normally used. And the lab tech said, by the way, don't worry, that's calibrated carpet. And so it actually was calibrated carpet. And so you have to think about the fact that that carpet is putting a certain load on that motor and so forth. And then you have a human who's interacting with that vacuum cleaner, and they may be bending over. And if you have longer hair, there were issues with the roller catching hair and causing harm that way and so forth. And so they're just completely unexpected things sometimes that you have to think about. And so when you do this analysis, really having that domain knowledge and domain expertise and understanding of the use cases. So if we look at the top of this pyramid, and this is a graphic out of that standard, you see that there are clinical scenarios. Those clinical scenarios are all about how do the people work with the technology, with the equipment. Doesn't matter if it's a medical system or a vacuum cleaner. The human to machine interactions have a lot of similar things to think about. Then, sorry. Uh-oh.
I just keep pushing buttons.
Okay. Okay, there we go. So then when we deal with the interoperability scenarios, we see that in order to make life easier for those humans who are interacting with the machines, we want the machines to interact with the machines. Right? And by having the machines exchange data with each other and kind of start understanding what that data does with related data from other machines, we can make the lives of the users a lot easier. That could be something like reducing alarm fatigue for a clinician. And so to enable all of this, we have different connectivity solutions. We saw and heard about ICE. We've seen things like the IEEE 11073 standards that have been talked about. There are a lot of different IEEE, ISO, IHE, a variety of different standards developers who are contributing to helping this community understand how to make those machines talk to each other. And then we have the underlying communication technologies, many of which are already existing within the healthcare delivery facilities that we leverage to make sure that these things can be implemented. We choose to use things like Ethernet, wired maybe for certain reasons. When you look at system design, you have to weigh out the pros and cons. If you choose to use wireless, maybe you have a whole different set of things you have to think about in terms of hazards and failure modes and things like that when you do this upfront analysis. And so an important issue is that when you connect these machines together, we're not just hooking up a wire from one to the other. When we looked at public policy several years ago, like with the FDA Safety and Innovation Act and things like that, we had to get to a certain place as a society. We had to move from paper records to electronic records. That was really the first big step that needed to be taken. Well, things happen when you make a big socio-technical move like that. But in order to understand how to deal with that, now we have to think about that connection as not just a simple wire. We need to understand the complexity of that piece of wire. One of the things you learn from vacuum cleaners is that if you drive too much current through a wire, it's going to explode and it's going to cause harm. And so we need to understand this is not just a piece of wire connecting these things. And even if it were just a piece of wire, there's still important things you have to understand about it. And so as you kind of go up this technology stack, you see that really what's important for the end user is what's presented at the application. And that's, a big part of what contributes to patient safety. But all of the different failures that could occur throughout this whole stack, which you analyze here, also contribute to patient safety. So everybody plays a vital part in this. It's not just the app developer, it's all of the technology implementation folks. And so as you deal with these different issues, kind of moving up the progression of technology implementation, then you can see that you have increasing levels of safety and security assurance. And then you know that I've done enough, if I have a decent level of assurance, to actually push this out into my design and start implementing it as I'm designing a product, as I'm figuring out how to integrate that product and designing a system around this. And so these are the kinds of things that, taking kind of that world of chaos that Sandy was telling us about and bringing some structure to it and managing the quality of it, these are the kinds of things that help us with that. And so I'd like to kind of close out by telling you about a very encouraging phone call I got just about a month ago. I got a phone call and it's all IP based, is like an IM based call and stuff like that. And I'm like, okay, let me see what's going on. And they're like, we understand you know something about vacuum cleaners. I'm like, oh no, here we go again. And so I'm like, yeah, I don't really work in that area anymore. But they're like, no, we really want you on this call. So I said, okay. And I jumped on the call with the customer. And this customer was an appliance manufacturer. And that appliance manufacturer had a very interesting request. They said, we develop, all kinds of different appliances, including vacuum cleaners that are connected to your Wi-Fi network that know not to fall down stairways in your house and things like that. He said a lot of our customers have medical devices that they're using on that same Wi-Fi network. How do we make sure we don't introduce new hazards to those patients? And that was a point, an inflection point for me, understanding that the type of work communities like this do is really making a difference in terms of awareness. Thanks.